you very much. Thank.
I'm here to talk about the prerequisites of AI and machine learning. Let me know when you're able to see my screen.
Yes, it is visible.
Okay. Okay. So, like I said, I am here to talk about the prerequisites. What do we need when we think about a project? Where to start? What is our current situation? So, in the screen, this is just like a starting screen, and you can see there are all a lot of top companies in the world that we have here. Uh, Apple, Amazon, Starbucks. What did they all do about this? It's all about data. Uh, Earlier, back 10 or 15 years back ago, we had some of the major vendors of database system were IBM DB2 and Oracle. That's all we could think about. Today, almost all the companies they are into data, and why is that? Because uh, gathering data is the fuel now, and you see we have, for example, EVs coming up, and like most of the companies, like they have grown like 10-fold times or 15-fold times in a span of like just 5 years. Take an example of Tesla. How did they grow to humongous multiple times? That's all because of data. They have been capturing data for every miles that we travel. Uh, so let's quickly jump into the other slide. What is the prerequisites? Uh, let's talk about the project life cycle. So whenever we think about a project, like Chandan talked about agriculture or on the AI, machine learning, and anything, first we try to understand what is the business issue. Uh, so uh, where do we stand right now? Uh, uh, Most of the public sector companies or the private sector in Bihar, typically if I talk about Bihar, I think we do need some data infrastructure as well. So if we talk about the data infrastructure, then we might think about what is the traditional. Do we have a traditional database system or data warehouse system? What is the need? How much data do we need? How much machine learning or AI can we implement there? And then that would ask us to go into the first channel, identify the root cause. What is the business impact? What is the current situation of our business? And then we can leverage. Okay, what is the data that do we need? Do we need a traditional database system, because or do we need a cloud based, if we have to implement a very high scale or very complex database? Uh, so uh, let's think about other companies. Like I work with a bank. It's an established company, and we don't have issues with the database or data infrastructure. It's already in place. So other challenges like on the strategy, like uh, the business leads, they build on a different strategies. Okay, we don't have any challenge with the database or data infrastructure. We already have that in place. So we have a current issue. Like for example, I work with a fraud strategy team, so we have multiple frauds that is happening on a day-to-day basis. So we collected those data from our infrastructure, what we have in place, and then we build certain strategies in there on the top of it. So think about on the AI or machine learning, what you can do with the perspective of Bihar. Uh, if you already have, for example, a system in place where you have all the data infrastructure, then you can leverage those infrastructure to further scale, further build on the AI and machine learning, to do some analytics and uh, try to make some profit, grow it from there. And so for example, some of the systems, like uh, let's talk about the healthcare system in Bihar. I think there is a dire need of data infrastructure as well. Uh, Take an example about BCMR. Last time I visited last year in India, I went to the office and they just have just one or two desktop systems. So I think at least they can start with somewhere to have some servers or traditional, where they can at least connect to different hospitals. Take an example, you can connect to different hospitals. That particular registration office can connect to different hospitals. And one particular student I met, and he had to go to the BCMR do couple of rounds to just get one certificate. So those are the challenging times that those all can be done pretty much fast. Uh, Here on the storage systems that I've been talking about, the on the left side you can see traditional warehouse and database systems. Uh, 15 years back, most of the organizations they used to have the traditional data warehouse and database systems. And what was the challenge here? Some of the challenges that they used to face was this was on premise. So the company used to take all the overhead of its scalability. It is not very scalable. Uh, if anything goes wrong with the system, then it was on the company to get it fixed. And uh, computation wise also it was not very fast. So these are some of the challenges that this system had been facing traditionally. And as the data has been increasing and increasing, for example, we create YouTube videos, we create so many Instagram images and GIFs. So data is increasing a lot, and it is increasing exponentially. So through with time, the organization they realize that these kind of servers and database systems, data warehouse system, that is we need something else. And within came the then came the picture of different web services, Amazon Web Services. Right now we have Snowflake, which is actually doing better than Amazon Web Services. Then we have I have just mentioned four big players in the market right now, but we have many more. Like Alibaba is there, and even Oracle and IBM they have their own cloud services. So we need to really understand like where we are now, and what do we need. Like if we have a small system, then particular or maybe for now a server can do the trick. But let's say agriculture needs a lot of data, agriculture space, uh, especially in Bihar, since Bihar is uh, agriculture is a major part and major vertical in Bihar. So uh, yeah. So we need to understand what kind of data storage systems we need, and we can take it from there. Uh, Explaining more on the data storage, we need to understand like how we actually use the data that is used for data science, machine learning, or AI. So typically when I have just put my experience what I used to work with Amazon. uh, so Amazon has a very big cloud service, Amazon Web Services, and this is how we used to have and we used to procure and use the data. So for example, we had a data lake. So data lake is like the name of the data lake was Andes. And uh, and uh, uh, it has just a raw data, like without just like a data dump. And on the middle vertical, we had a data clusters. What you have in market is Redshift. So Amazon uses Redshift clusters, uh, and those Redshift clusters, for example, Amazon has different verticals. Let's say retails, music, ads. Amazon is in ads now as well, and then finance and products. So I was in products. Within product specific, I was with Amazon Alexa team. So suppose this is me, and I was using this product Redshift cluster. So I used to, and also yes, this particular Redshift cluster, they have both storage and compute. So I'm not dependent on the computation or the storage power of my particular independent laptop. I can use the computation of this cluster, and this cluster is scalable. Actually, I didn't do the slide mode. So but yeah, you can see. I'll give you an example of this cluster in detail. But if you see, I can access this cluster, I can access its storage and compute, which is huge. And that is what we need for AI and machine learning. uh, for AI and machine learning, you cannot depend on just the power of your laptop or computer. You need a lot of data, and this cluster is synced with the data lake. The data lake has all the data related to finance, ads, music, retail, and then you can imagine what is the capacity of the data in the data lake. And this is all not on-premise. This is not on anywhere in campus. It is located somewhere remotely in the data centers, huge data centers, and they have multiple data centers, and like there are multiple data lakes which are synced to each other, so that you don't lose the data as well. So this is like a brief background of how the architecture looked like. So there are different team members. Somebody worked with finance, somebody worked with a music team. They can all access the single data lake through their independent clusters. And the good thing about this system was that it was very scalable. Let's see on the right side if you see the picture here. So there was one. This is just an example of one particular Redshift cluster. So you see there is a leader node. So this node just what it does is that it it manages uh, all other nodes. The rest of the nodes are like compute and data nodes. So what advantage what we had is that you see we have two here. We can add as many nodes as we want. So that increase the scalability. And once you try to query or fetch a computer data, it it uh, it processes the data in parallel. So it will throw some data on this node, it will throw some data on the other node, and the computation is done in parallel. And once it is done in parallel, it is very fast, unlike, let's say, a traditional IBM DB2 database. So that is what we need for the AI and machine learning. So it is we need faster computation, which is provided by these kind of aid cloud-based database solutions, and scalability. Like suppose if you still need more data, then we can just keep adding the number of nodes. And here we have the data lake, or we have different Amazon Web Services like S3. You can use S3 as well, or sometimes the data lake is synced with S3 so that a person can pull the data from data lake or the S3. Let me know if you have any questions. I'm just quickly going through this. I'll go to the. Okay, yeah, that is all from me. Thank you.